So in this week's class, we're going to talk about iterative development practices. So in the last class, we covered the basic systems analysis and design process with respect to doing requirements analysis, design, implementation. So I guess the steps were investigation, requirements analysis, design, prototyping, maintenance, review, or some amalgamation of that. This was also referred to as the waterfall process or waterfall systems development. We also pointed out some of the pitfalls of the waterfall model, which we specifically talked about in some of the classroom discussion. And in this class, we're going to talk about more modern systems development practices, particularly what we refer to as iterative development. So in this section, we're going to discuss the philosophy of iterative development, what that actually means, and we're going to talk about management and development practices that go on with respect to iterative development. So let's go to our first slide here. So evolving systems analysis and design. The systems analysis and design cycle, which we discussed last class, originated from manufacturing and construction. It originated from how we produce hard goods. So this was founded on the basis that when developing physical things, after the fact changes could be extremely costly to do. So they had this very discrete, phased process. Investigation, requirements analysis, systems analysis, design, prototyping, things like that were very discrete, so that when you finished one, you went along to the other, and that you completed one, and really focused on completing one to get to the next. So a hardware-oriented method was adapted for software development because this was kind of the natural progression. But people soon realized that software development is much different. And this could possibly be because of the fact that software is intangible. Also could be because of the fact that changing software is a lot less costly, so people are more inclined to change their requirements because they know they can. Who knows? We don't know the reasons. But possibly because of its intangibility, software requirements in software systems development, it changes more often. These development projects and the requirements within them change much more often. So, for example, clients, may not know exactly what requirements they need before reviewing a working prototype of the software and having a chance to comment on it. So, unlike something that you can tangibly hold, people don't know really what they're working with software until they actually see it, or that someone's actually coded it to a degree to which they can actually use it. You could also make the same case that this is the way that hardware could work as well. But since historically things have been so costly, they haven't, development processes haven't necessarily worked like that. So I'm going to use a term that we've used in previous classes with respect to design, and that design is a wicked problem, where it's a problem whose requirements and limitations cannot be entirely known before completion. So, given the pitfalls of systems analysis and design, and the problems that organizations have had with it, enter this notion of iterative development, which is a cyclic process of prototyping, testing, analyzing, and refining a process or a product so that you can continuously have something that you're working on and prototyping and getting feedback on. So it's based on constant and multiple forms of feedback, and we'll talk a little bit in some of the future slides about what types of feedback there are. But for example, based on the results of testing and user feedback, the most recent iteration of design, changes and refinements can be made, but it's based on testing and getting that feedback by which you can make those changes. So interaction with the design system is used as a form of research for informing and evolving a project. Using successive versions, and hopefully successful ones, or iterations of a design that are implemented and ones that give the users the opportunity to look at and to touch it and feel it and to experience what it's going to be for them. So the whole goal of it is it's ultimately intended to improve the quality and functionality over design over shorter spans of time than what happened with the waterfall development process. So let's talk a little bit about the different types of iterative development. And I put this slide out there because we're just going to talk about a very popular approach. And there's different versions of this popular approach, which is called Agile. And then there's also other approaches that are viewed as equivalent to Agile, all under the auspices of iterative development. So, I put in the first bullet there, there's much more to this topic than what we're going to focus on. But there's many ways that IS people, software engineers, developers, software developers, engineers, analysts, etc., go about the practice of iterative development. Some of this is called adaptive software development practices, rapid prototyping, rapid application development. When I took an information systems class, we didn't talk much about Agile. We talked about rapid application development. And Agile, or iterative development, is just an evolution of that. There's other processes related to Agile, such as the Agile Unified Process. There's something related to it that I don't have on this slide called the Rational Unified Process, which is very much, which is made by the makers of Rational Software Project. They make all sorts of project management tools. There's Crystal Methods, Disciplined Agile Delivery, Dynamic Systems Development Method, Extreme Programming, which is part of Agile that we're going to talk about in depth later on in the slide presentation. Feature-driven development, which Agile incorporates many aspects of what was previously known as feature development. Lean software development, we talked about Lean Six Sigma in some previous courses. Scrum, which is what we're also going to talk about with respect to Agile management practices. Scrum Ban, which is a mixture of a Kanban, which is a little bit less of an organized engineering practice that goes on, which is considered another form of iterative development that's used in both hardware and software domains. But in this presentation, we're going to look at the products, processes, and practices under the auspices of Agile, which is an iterative development type, if you will. So let's look at this thing called Agile. It's based on an iterative development philosophy, which we've talked about with tight development cycles as opposed to very discrete steps, which is like we had in the waterfall development process. And it's also based on requirements and solutions evolving through collaboration. And this occurs between teams that are what we refer to as self-organizing and cross-functional. Self-organizing in the fact that this process, this methodology, is not really telling us to do anything that's contradictory to our own human behavior. It's something that's very loosely based so that teams can self-organize around a philosophy as opposed to proceeding down a very discrete series of steps of a methodology. And then these teams are also cross-functional with respect to the fact that they don't just focus on coding or requirements. They're actually working on requirements over these tight development cycles and then actually implementing those requirements and doing the testing, not to mention. So they become very cross-functional in that dimension with respect to doing multiple tasks. If you were to look at it from the lens of the waterfall development process, but they're also cross-functional with respect to the fact that they don't just work on a particular type of development. They don't just work on user interfaces or work on other types of database development or business logic. With respect to Agile development, in terms of diversifying how your resources work on what stuff, people tend to take on different functions across the entire project. And from a business perspective, this is risk management. This is how you diversify risk. Because what if you have somebody working on user interfaces and that person gets hit by a truck? Well, then you have nobody else to work on user interfaces. You have to diversify across functional dimensions, which I'm just talking about, and also with respect to phase dimensions with respect to something like the waterfall processes or phases within the waterfall development process. So another thing about Agile is it promotes the idea of adaptive planning and evolutionary development, where requirements change all the time, and it's up to the engineers to design for today and adapt to what may change down the future if and when it does. and evolutionary development from the point that you're constantly working, testing, giving demonstrations of what you're doing, putting things into people's hands so that you can elicit feedback, automating testing so that you can get feedback with respect to tests that are going on, so that you're always taking these forms of feedback and constantly evolving them. You're taking what we refer to as empirical forms of feedback from eyes, sense. The term empirical just means eyes, sense, touch, feel. The five senses, and taking what emerges from the five senses and using that to evolve software. So, like I've talked about before, Agile uses tight iterations, usually 2 to 3 weeks. Sometimes the tighter the iteration, the more in tune your software development team is. If you move from something like 4 weeks to 3 weeks, that means you're getting better. If you move from 3 to 2, that means you're getting really good. And then every once in a while, you'll come across an Agile team that's doing things in 1 week iterations. And that means they're really in tune and they're really buzzing as a team. So they work in these tight iterations for the entire development cycle or for the entire life of a project. So that is, one distinction with respect to the many distinctions between Agile and Waterfall, is that investigation, prototyping, all of the different phases of the Waterfall development cycle, from investigation, analysis, design, implementation, prototyping. This can all take place in 1 week with respect to Agile. And that's a very important distinction that you should understand with respect to iterative development versus waterfall or phase development. So let's look at kind of the philosophical aspects of Agile development, of iterative development. And so many years ago, I think there were a number of pioneers of this process that got together at some ski resort in Salt Lake, and they developed what we refer to as the manifesto for Agile development. And this is, just a philosophical approach to how you go about doing these types of things. And then from later on, in later iterations of meeting and developing alliances and things like that, they've developed the rituals or the methodologies. And so the manifesto for Agile software development is simply that you have individuals and interactions, particularly face-to-face interactions. It's very face-to-face intensive over things like processes and tools, over regimented use of a technology or use of a process. It's really about individuals and the interactions with those individuals. Another part of the manifesto is having working software over comprehensive documentation, where working software is the primary measure of progress. Another part of the manifesto is customer collaboration over contract negotiation. This is why, as we'll see in some of the later slides, that Agile management practices involve you actually having a product representative as part of your team. So that person doesn't sit on the outside. That person is ingrained as part of your team. And then the fourth component of the manifesto is responding to change over following a plan. You have to embrace change. Requirements change. Last class, when we talked about waterfall development, we particularly talked about the fact, in some of the pitfalls, we talked about the fact that when you go from a requirements phase to a design phase to an implementation phase, there can be a considerable distance in terms of time. And then within that time, requirements tend to change. Users' priorities tend to change, which manifests themselves in changing requirements. You have to be aware of those things, and that's where iterative development evolved from. So let's move to the next slide and talk about the 12 principles of Agile. This is once again, more philosophical in nature, where customer satisfaction by rapid delivery of useful software is one principle, where the development team must welcome changing requirements, even late in development, is another one. Working software must be delivered frequently, in weeks rather than months. Working software is also, like I said, the principal measure of progress. Sustainable development. You have to be able to maintain a constant pace so that you're not working super hard to get done with one phase to move to the next. You're constantly maintaining a pace where people have a combination of balance in their work environment and in their lives so that they continue to produce at a sustainable rate. In principle number 6, you have close daily cooperation between people and developers, between particularly business people and developers. Once again, in principle 7, face-to-face conversation is the best form of communication. Whether or not you have a co-located team, to have all those cues, to have face-to-face interaction, whether it's over Skype, Google Hangouts, or something, there needs to be face-to-face interaction in one form or another. Another principle is that products are built around motivated individuals who should be trusted. Your developers are good. You bring in good people as part of your team, and you give them trust and enact that trust so that they can do the best job as they can, as opposed to something something like micromanagement, where they don't get the chance to think for themselves, to think about the whole in relation to the parts they're producing. Another principle is that continuous attention to technical excellence and good design must be adhered to. We'll talk a little bit about design patterns later on in the slide deck. Another principle is simplicity, where you have to maximize the amount of work not done. And this is a critical piece. This is something that when I used to work on these teams and lead these teams that I emphasized a lot, is you want to maximize the amount of work not done, and that is essential. Simplicity is one of the keys. Simplicity and reusability are two huge keys of software, and when you make things reusable, you potentially also make them simple because you don't have to test something different every single time. You've already developed the test for that reusable component that might be reused throughout your entire system. So principle 10 is a big one. Another principle is to have self-organizing teams, and that goes a lot with trust, where you allow people to do what they need to do to get the job done. And then principle 12 is to have a regular adaptation to changing circumstances. And that's effectively where you need to embrace change. And I'll use that term a little bit later on when we're talking about extreme programming, or the principles of extreme programming. But these are the 12 principles that they also came up with when they met and came up with that manifesto. So this really embodies the philosophy of iterative development and agile development. So let's move to the next slide and let's talk about the iterative, incremental, and evolutionary aspects of Agile, of iterative development, of Agile as an enactment of iterative development. So Agile methods, like we've talked about or I've alluded to, they break tasks into small increments. And it doesn't involve a lot of long-term planning. You design for today, not for tomorrow, because if you're always designing for tomorrow, you're constantly, you end up writing a lot of code for what may or may not come to be. And that becomes very difficult to test and to implement. Effectively, what it evolves into is you have what I like to refer to as dead code. Code that never gets executed. Code that's impossible to be executed based on what users are doing, because it may be needed at a later time. It's not a good idea to do this. You have to kind of be in the present with respect to Agile development. Another part of it is that iterations are short time frames, and we talked about this. And what this refer to is what they refer to as time boxing. Time boxing occurs with respect to iterations, by cutting things off explicitly after 2 to 3 weeks, whether or not you've finished all of what you intended to, and that is sometimes a very difficult thing. And then you also have time boxing with respect to tasks, because sometimes if you're not careful, the actual tasks or things you do within an iteration can go on indefinitely. You have to time box things, and if you can't get them done, you have to put them back on the list, which I refer to as a backlog. So another aspect of this is that developers, once again, are cross-functional, just to emphasize this, meaning that they work on the estimation of planning, requirements analysis, design, coding, unit testing, and acceptance testing, and working with users to know whether or not what they've done is acceptable. Another aspect of this is that at the end of the iteration, a working product is demonstrated to stakeholders, and this is a critical piece of Agile development. That at the end of a 2 or 3 week iteration, you have working software. So you design to continuously have something that's working. And this is difficult many times because a lot of times there's things that need to be developed that are kind of deep down components that may not involve a user interface. But the reality of it is it's going to interact, that particular piece, such as something that interacts with a database, is going to have to interact with the user in some way. So you might as well do what you need to do to bring it to the forefront so that a user can see it and touch it, feel it, maybe work with it, and give some feedback on it, most importantly. So the last aspect I have on here is that Agile tries or attempts to minimize the overall risk of the project and allows the project to adapt to changes very quickly. So there's also some criticisms about that, and we'll talk about that in a future slide about whether it does minimize the overall risk. So let's move on to the next slide here and talk about how Agile facilitates efficient and face-to-face communication. So each Agile team has someone who actually represents the customer, called the product owner. This person is appointed by the stakeholders, not the people in the Agile team, but if you're in a small company, maybe appointed by the CEO or the CTO. If you're in a larger company, it's maybe appointed by someone who is who has a stake in the success of the project in one way or another. But the point is, it's appointed by a stakeholder, and those stakeholders are usually, almost always, not part of the development team. And it's best for the stakeholders and not people who are part of the development team to appoint that person. So this person must also be available for developers. They are an ingrained, embedded part of the team, whether it's at the end of an iteration or in the middle of an iteration, to be able to answer questions about a particular task. At the end of each iteration, stakeholders and the customer representative, this product owner, they are the ones who review progress and reevaluate priorities. It could be that the priority scheme or the priority list that you had in a particular order after a particular iteration, based on what you've done, doesn't make a difference anymore. You have to reprioritize, and you have to be able to adapt to those reprioritizations. The last aspect I have on here with respect to efficient face-to-face communication is that this is intended to actually help optimize the return that you get from engineering efforts and to ensure alignment with customer needs and company goals, because you have that person that's a representative of the stakeholders embedded in your team. So let's move on to the next slide here and talk about the fact that Agile has very short feedback loops and tight adaptation cycles, and talk a little bit about what that means and kind of what people do. So, like I've said, it's short iterations, 2 to 3 week cycles, usually. Every once in a while can be 4-week cycles, and then if a team I think is doing really well, 1-week cycles. But I would offer a word of caution to anybody attempting to do 1-week cycles off the bat. You have to have a team that works very well together and understands Agile practices very well, with not just in general, but with respect to that company's culture, the company's culture that you're in. So, with respect to these very short feedback loops and tight adaptation cycles, one of the things that people do during an iteration is they have what I like to refer to as the daily stand-up. A lot of people refer to this as well, not just me. And the daily stand-up is something that just has 3 questions, and you get in front of your team and you talk about, and you also track the metrics. You usually have a Scrum Master who tracks the metrics, or a team leader who tracks the metrics with respect to 3 questions. And that's, what did you work on yesterday? What did you do yesterday? What are you going to do today? And do you have any roadblocks or impediments that keeps you from doing what you intend to do? And so the team goes around, each person answers those 3 questions, and the meeting usually lasts about 15 minutes. So let's move on to the next slide. Let's talk a little bit about the focus on high quality, what this intends to do. So the focus, with respect to Agile development, is to be able to participate in a high-functioning Agile team. So a developer must know specific tools and techniques, such as these ones that I have listed below, and we'll talk a bit more about some of them a little bit later on with respect to Agile management with Scrum and extreme programming. So to be able to focus on high quality, people in an Agile team, which sometimes, one of the criticisms of Agile is that they have to be quite senior to be able to know all this stuff. They have to understand the aspects of continuous integration, which is something I'll talk about, which basically means that you have, kind of the bullet listed below, automated unit testing, where you're continuously running these tests. And because you're always checking in code, you're always running these tests to know that everything is passing, and if something fails, if there's a problem, you know about it sooner rather than later. So, continuous integration is something you have to know about, with also very much related is automated unit testing. You also should be comfortable programming not by yourself, but in pairs, where a lot of times you'll have somebody who's driving, who's writing the code, and then somebody who's sometimes sitting behind them actually thinking about what needs to be done. And then they switch off, and there's constant collaboration. And really what this helps developers do is write the best code possible, because you're usually working a lot harder, and you're usually thinking a lot harder with respect to the fact that you have somebody behind you or working with you than if you're doing it by yourself. It's just human behavior. So some other aspects with focusing on high quality is that you have to know about test-driven development and code coverage. And we talked about this in some previous classes, and I'll talk about it again in some successive slides. You also have to know to focus on high quality, you have to know about software design patterns. Design patterns are intended to routinize a lot of what people consider kind of takes software development as an art and turns software development into a more routinized engineering practice, which is where things should be going, because then you're more able to easily identify patterns and work with those patterns especially if someone else implemented them. So you also have to know about domain-driven design, designing within your particular domain of interest, and how to refactor code. And a lot of times refactoring code takes something that wasn't in a design pattern and turns it into one. So let's try to understand Agile a little bit more and the differences between Agile and Waterfall. And I like to classify it as adaptive versus predictive methods. So we've talked about this a little bit before. Agile is clearly adaptive. Systems analysis design, the waterfall method, is clearly predictive. So, waterfall methods are predictive because they focus on analyzing and planning the future in detail. They focus on a very linear, sequential path to getting to some sort of utopia and having this perfect system at the end of the day. And that end of the day can be 3 to 5 years many times. So, because of this, waterfall methods are really only good at catering to the known risks. And in theory, they are able to report on exactly what features and tasks are planned for the entire development process, but we also know that's not necessarily true. And that also waterfall methods rely on effective early phase analysis, where you spend a lot of time investigating the problem, developing a feasibility analysis, doing a requirements analysis, and then moving into design. It's those preliminary phases that are the most difficult. And what people came to the conclusion of was that they were nearly impossible to do really, really well, because things changed too much. And the more you focused on doing them really, really well, the more time went by and the more requirements changed. So what you thought you were doing really well didn't manifest itself that way to the customer. So in contrast, Agile methods are predictive, where it's kind of this rolling wave of continuous planning. There's constant planning always going on. It identifies milestones, but it also leaves things very flexible in how to reach them, because there's an understanding that these milestones may and will change. And so you have to quickly adapt to these changing realities. So a lot of times what this means is that developers may have difficulty describing exactly what will happen to the future. And it also requires, may require more senior developers to actually embrace such a philosophy that requires you to know some of the things that we talked about on the previous slide with the focus on high quality, and to just be able to work in a highly functioning team. So let's move on to the next slide and talk about criticisms, as we've kind of alluded to that in the past slide. And that's, nothing is perfect, right? And there's a lot of criticisms of agile and iterative practices, even if it does represent an evolution to waterfall, which many people commonly agree is a rather flawed practice. But, some of the criticisms are that agile can be inefficient in large organizations. It can also be very difficult to employ agile practices in more complex projects. It can be too extreme in the fact that there's a lack of planning. It can also be difficult if users really have no idea what they want and don't really form such an idea, over the course of successive iterations. If that target keeps shifting by long distances, then it's also argued that you're really not getting anything done with respect to iterative development. And then the last bullet I have here is that it can be difficult if there is no automated testing. So automated testing with respect to iteration, I believe, and many others who are kind of the founders of this practice, believe that automated testing has to go hand in hand. But I will also say that with respect to bullet point 2, in that it can be difficult to employ more complex projects, I actually have to disagree, because one of the first iterative development projects that I ever worked on, the first time that I ever worked in an agile team, was coincidentally on the most complex project that I've ever worked on. And I would say it actually works really, really well, and can work really well when you have big projects, when you have people who are not just software engineers, where you have physicists, hardware engineers, electrical engineers, civil engineers, field engineers, all different types of people working on these types of projects. The agile or iterative philosophy really can help to bring together all the people in that team, in that big super team, more often than not. And so I think the philosophy can be a good thing, even in more complex projects. But I will predicate that and say that, or preface that and say that's my opinion. But there are a lot of people who would say that bullet 2, with respect to bullet 2, that rapid prototyping and agile development, iterative development, can all be very difficult to implement in more complex projects. So let's drill down a bit and talk about agile management and agile development as two practices with respect to iterative development. So what we're going to talk about with respect to agile management, is a practice of agile management, is what we refer to as Scrum. And so Scrum is a term from rugby, where it means that it's a method of restarting play. Now, Scrum in software development is a way for teams to work together to actually develop products. So product development using Scrum occurs in small pieces, just like we've been talking about, with each piece building upon previously created pieces. So building products one small piece at a time encourages creativity and enables teams to respond to feedback and change, and to build only exactly what is needed. So once again, we get back to that concept of maximizing the amount of work not done. And so with Scrum, there's a prescribed way to manage the short, rapid cycles of an agile product and team. So it takes an empirical approach, which we talked about before, meaning that a team accepts that a problem can never be fully understood or defined, and that you just go off experience, you go off what's sensed, you go off the feedback that's been given to you to define what you need to do over the next iteration. And so instead, the team focuses on maximizing their ability to deliver quickly and respond to requirements that are constantly emerging and ones that are constantly changing. So let's move on to the next slide and talk about some of the terms with respect to Scrum. And I apologize, there's a lot of terms. So that time period that typically takes one full is what we refer to as a sprint. The Scrum team is the development team, team lead, which is referred to as the Scrum Master, and then someone appointed by stakeholders, like we've talked about, called the product owner. And that product owner is the person responsible for maintaining what I refer to as the product backlog, or the list of tasks that are prioritized that represent the interest of the stakeholders and ensure the value of the work of the development team. And so the Scrum Master, which there's also certifications to become a Scrum Master by the Scrum Alliance, is the person responsible for managing the Scrum process, for enacting the Scrum process, and making sure it's used correctly and maximizing the benefits of such a thing. And so the development team, which you already know about, is a cross-functional group of people responsible for delivering potentially shippable increments of the product at the end of every sprint. Another term we have here is the burn down chart. And so what this refers to is literally a graph that pretty much everyone looks at during an iteration of a sprint, where it literally just tracks the time you've been working on tasks with respect to what was estimated. And if you burn that time down to zero, then usually that's a mark that you're a successful team, that you're working on all the tasks that you need to be doing. So there's a sprint burn down chart, and then there's also a release burn down chart, which is sprint level progress of a completed product backlog with respect to items in the product backlog. So the product backlog, which I've talked about, is just simply a prioritized list of high-level requirements. And so what happens with respect to every planning phase, which we'll talk about in the next slide, is that these items in the product backlog during planning will get broken down into very discrete, finite tasks of what needs to be done to complete a particular item in a product backlog. So sometimes there's a one-to-one relationship between what's in the product backlog and what goes into the sprint backlog. Sometimes it's a 1-to-10 relationship, and you only get one item done in the backlog, or from the product backlog. It all depends. So those things that get broken down are called tasks, and those are just the work items added to the sprint backlog at the beginning of a sprint. They get broken down into hours. And so each task should not exceed, and this is a general rule of thumb, each task should not exceed 2 days. That's a definite no-no. But it's actually much more common to have tasks not exceed 1 day. So you really want things to break down into single-day tasks. And a lot of times there's even an accompanying philosophy that says if you don't get it done, you throw it away and you all start from scratch. Because it's better to throw it away with what you've learned and to start from scratch than continuing to work on something that may or may not be kind of cobbled together or is hobbling along. And so also some other terms that's important for Scrum is to have a definition of what it means to have a task done. So this is the exit criteria to determine whether a product backlog item or sprint backlog item is complete. In many cases, the definition of done, or what it means to be calling a task done, requires that tests should be successful. So I've done this many times, and what it means for a task to be done when I've led agile teams is that you have unit tests with proper code coverage, 90% or above of code coverage, which means that of the code that you've written to implement a particular feature, 90% of that is actually being tested by coded tests that you've also written. That you've checked in your particular task, the code that you've implemented with respect to your task, into the main source tree, and that you've run all of the tests and ensured that all of the tests for the entire source code or code base run and pass successfully. That requires a lot of work to call something done, but that's what's required for this type of development process. So another term that we have is the notion of velocity. And if you took calculus, you understand what velocity is. But with respect to this, velocity is the total effort a team is capable of in a sprint. So it's just an empirical kind of cumulative representation of what a team can accomplish. And, if you're not estimating with respect to your velocity, you're kind of ignoring reality at that point. So that's what that measure helps you do. Stay in touch with reality of what your team is really capable of. And so we've talked about this term, this next one here on the Scrum terms list, impediment. And that's anything that prevents a team member from doing what they need to do, from completing tasks, from working as efficiently as possible. And then the last term I have on here is kind of a funny one, and that's sashimi. And that's an actual report that something is done. verifying that your task is done or that a product backlog item is done for stakeholders to be able to view. So the definition of done may vary from one Scrum to another, but this term, what this actually means, must be consistent within the team. So let's move to the next slide and talk about sprint planning. So sprint planning is held at the beginning of a sprint cycle. Every 7 to 30 days, you have a sprint planning meeting, and the work that's to be done during the sprint is estimated and selected. The team actually gets into a room, they estimate tasks, they break down what those tasks are going to be, what needs to be discretely done to complete the task, and what the hours are going to be. Now, I actually used to do this. I tried to take hours out of the equation, but it's very difficult to do so. People just want to use hours. And ultimately, in the last project where I did this, I was defeated. People just wanted to see hours. It just made them feel better with respect to estimating tasks in terms of hours. Whether it was a 1-hour task to a 4-hour task to a 24-hour task, it didn't matter. They wanted hours. And so you have to go along with what your team wants. And I did. And it actually helped a lot. But people get into a meeting, sprint development teams, they will get into a meeting, and they will estimate how many hours a task is supposed to take, and a lot of times it'll be a fairly democratic process, where you'll vote on how many hours you think something should take, and you'll come to a consensus on it. So during that time, during these sprint planning meetings, a sprint backlog is prepared that details that time that it will take to do the work with the entire team, involving the entire team. And so what this also does is it identifies and communicates how much of the work is likely to be done during the current sprint. Now, there's an 8-hour, a lot of times in practice, there's an 8-hour time limit to these planning meetings. Some of these meetings, and in general meetings, you just have to be careful. Meetings can go on for long periods of time. And so sitting down for a meeting is many times a diversion to people doing actual work. So you have to set a time limit. So what I've done in the past and what I've seen in practice, and I've derived what I've done from best practice, is that during the first 4 hours, it consists of the entire team, product representatives, stakeholders. They have a dialogue for prioritizing the product backlog and what's going to go into the sprint. And then the second 4 hours is just the development team, where they hash out what they need to do for the sprint to get what the stakeholders want them to get done. And this results in the sprint backlog. So we alluded to this before. We talked about this notion of daily meetings, or what I call the stand-up. And some think that this idea of having a stand-up meeting, versus one where people get in a conference room and sit down every day, originated from the former Secretary of Defense, Donald Rumsfeld, where he had a standing desk, and when people came into his office, they always stood. He wouldn't let them sit down because he found that behaviorally, if people were always standing, they were getting their points made, and there was a much quicker interaction. Things were just getting done faster. So the daily stand-up became something that was widely implemented in Agile practices as well, and I think that's where it actually came from, and a lot of people do as well. And he was, a very controversial man, but also pretty smart in a lot of the things in a lot of his behavioral practices and that he did. And there's a reason the guy became Secretary of Defense, whether or not you choose to like him. So each day, a project team communicates, those 3 questions that we talked about. So there's project team communication every single day during a sprint. And, this is the daily scrum. And all members of the development team, have to come prepared for the meeting. It starts precisely on time, whether or not everyone's there. It always has to start precisely on time. Oops, let me go back. The meeting should happen at the same location and same time every day, and the reason that needs to happen is because other people might want to come to the meeting, such as your stakeholders, such as the CEO, and see what's going on. You have to invite them. You have to open the books and let them come in. So the meeting length is usually time-boxed, and I was always pretty adherent about setting that time-boxed time to 15 minutes. And then, like I said before, all are welcome, but normally only the core roles speak. And I'm going to talk about this notion of pigs and chickens, which is kind of a funny thing that people use with respect to Agile. And so during the meeting, each team member answers those 3 questions that you talked about before. What have you done today? What are you planning? What did you do yesterday? What are you planning to do today? And do you have any impediments or stumbling blocks that prohibit you from doing what you would like to do or what you prescribe to do? So, any impediments or stumbling blocks that are identified during this meeting is documented by the Scrum Master. You have to document these impediments. You have to document everything. And as the Scrum Master, you have to be the one to work towards resolution outside of this meeting, to making sure that your developers have little to no roadblocks, period. So that's what happens. So we've talked about what happens at the beginning of a sprint, during a sprint. Now we're going to talk about what happens at the end of a sprint. So at the end of a sprint cycle, this is where you have a review meeting and a retrospective. During the review, you talk about the work that was completed and the planned work that was not completed. What did you get done? What did you want to get done that you didn't get done? And you have to be very fair and honest with yourself during these assessments, because this is what manifests itself as your velocity metric, which you use to plan for the next sprint. So, you want to present the completed work to your stakeholders, aka the demonstration, and you want to time box this once again to a 4-hour time limit. So also you have the sprint review meeting, and then you have what's known as a retrospective, where this is where the development team has a very honest reflection of what they did right and what they did wrong. So you debate, you reflect on the past sprint, and then you debate how to make process improvements, based on what did get wrong. If you're not happy with someone in your development team, you have to air it. You have to let it be known diplomatically. We're all humans, and humans get in confrontations, and there's discrepancies and things like that. The retrospective is where you have to be honest with one another to move forward, and sometimes that gets difficult. So 2 main questions are asked in the retrospective. What went well during the sprint? What can be improved? Usually you want to limit these meetings to 3-hour time limits, and this meeting is facilitated by the Scrum Master. And so I've been the Scrum Master many times, and I always use the sprint retrospective as an excuse to get out of the office. And I would actually hold these at my favorite pub, or some sort of craft beer brewery or something like that. And a little bit of alcohol helps keep people honest, loosen everybody up, get them out of the office, where you can talk about the real issues. Because at the end of the day, it's about humans coming together to work towards a common objective. And you want to get people to bond as much as possible so they can be as honest with each other as possible, so that you can get as much done as possible. So I talked about this notion of pigs and chickens. The people committed to completing the Scrum are pigs, right? These are typically the programmers. People who are involved but not committed are the chickens, right? These are typically the managers and the customers. And it comes from this funny little cartoon where, if you look at it, it's, hey pig, I was thinking we should open a restaurant. And the pig says, well, I don't know, what will we call it? And the chicken says, how about ham and eggs? And the pig says, no thanks, I'd be committed, but you'd only be involved, because of course, it requires the pig's life. So that's kind of the funny idea behind pigs and chickens. And that's why during the stand-up meetings, it's only the quote-unquote pigs that are the ones who normally talk, because they're the ones who are committed. The stakeholders are, during the sprint, they're only involved. So, we talked about agile management practices and I gave you an example of that with respect to Scrum. There's other ones. But now we're going to talk about agile development practices, and I'm going to use the example of extreme programming. So, extreme programming, or XP, it's a controversial process where it's a software development practice that's, at a high level intended to produce high quality software, but involves 4 basic activities that really changed. Now, a lot of people are doing this now, so it hasn't changed the game so much, but when it first came out in the early 2000s, it really changed how people thought about how to develop software. So it involves 4 basic activities, and feedback loops for all of them: coding, testing, listening, and debugging. So let's talk first about the practice of extreme programming with respect to coding. So, extreme programming basically says that the only truly important parts of the system's development process is coding. So, coding is used as a way to reflect and to figure out the most suitable solution. The process of coding helps communicate thoughts. You kind of put your thoughts down on paper, per se, and use what's there as a process of reflection to make things better. You can use code to demonstrate a complex problem, to let people know what you're thinking. And then other developers can give feedback by coding their thoughts. And also, what's encouraged in XP is that you work together in pairs, which I talked about before, where you have one person who's driving, actually working at the keyboard, writing the code, and then that person is interacting with someone who's behind them or next to them that's thinking more deeply about what needs to be coded and kind of offering direction. So this is coding in terms of with respect to extreme programming. Now, let's move on to the next slide and talk about testing, where the philosophy of this is that if a little testing can eliminate a few flaws, then a lot of testing can eliminate many more flaws and perhaps, most of the flaws. So within testing, there's two critical paths. So you want to write as many tests as needed to achieve maximum code coverage, which is the percentage of code that is actually being tested. So for example, all statements or conditions in an if-then-else statement. So you probably have seen this in Excel. You have an if statement and you have two conditions. And then in condition 1, you have something happen, and then in condition 2, in the else, you have another thing happen. In code, you want to be able to execute the effects of what happens for the if statement and then the effect of what happens for the else statement. If you have a single function that just has an if-else statement, and you execute both of those conditions, then you've achieved 100% code coverage. So many times these tests are what are called unit tests, where individual units of source code are tested. And those units, so a unit, for example, in the example I just gave, a unit is the thing that happens in the first part of the if statement. And then another unit would be what happens if the condition is not met, and then it proceeds to the else part of the statement. So you would have two different tests, two different unit tests to test both of those cases. And so those are unit tests, and you want to write those to achieve maximum code coverage. And then the other thing you want to do with respect to testing is you want to automate those tests. And we've talked a bunch about automation thus far in this lecture, where the point is, when I talked about the definition of done list, you want to rerun all of your tests, make sure they all pass with respect to the new tests and new code that you've added to make sure that you didn't break anything unintentionally. So this way, if you add code that accidentally does break something, you know right away, as opposed to 3, 4, 6 months down the line. So this is referred to as, and I put this in bold because this is an important term, continuous integration. And so one way to go about testing and continuous integration, or putting all the nuts and bolts together for continuous integration, is to use what I've referred to in the past in other lectures, and of course I've talked about it a bunch in this one, test-driven development. So the philosophy of test-driven development is you write a test, and that test has no code that it's implementing, so it's automatically going to fail. And then you write the code to make it pass. So I kind of list these steps out in a little bit more detail here. You code a test before writing any implementation code. You run all the tests to see if the new one fails, and it will, because you haven't implemented anything. So then you write the minimum amount of code necessary to make that test pass. Then you run your tests to make sure they all pass. Do any refactoring necessary to optimize your code to make sure that you don't have anything that you don't need. And then you continuously repeat this process until you've completed a particular task that was listed in your sprint backlog. And ultimately, the sum of all these parts that we're talking about here will equate to a fully tested function that completes something in the product backlog. So that's testing in a nutshell. And it's a huge part of things at the task level for iterative development, agile development, as part of extreme programming. Testing, automated testing, continuous integration of tests is critical. So now let's move on to the next slide and talk about listening. Right? This is a little bit easier, you would think, but it requires people to really be cross-functional. So programmers must be business focused and listen to what the customers need the system to do. They have to understand these needs well enough to give the customer feedback, and then they have to communicate to customers how the problem can be solved. And what I also put here is don't eschew the details. Don't make it seem like what you're doing is a black box to someone else. Let them know that something is difficult. Let them know what's required. Involve people. Let them know the complexity of what they're asking for. Because it could be very well that someone might think something is very easy and they can't envisage how something would be difficult to them. But it could very well be very difficult to the software team. You shouldn't blur the details, especially for your stakeholders. Let them know that something is more complex than what it seems, because it will happen more often than not. So now let's go to the next part of extreme programming and talk about designing. And so this is where I've talked a little bit in the past, in the previous slides about design patterns. And so this is where you want to create and use design structures that organize and formalize logic in the system. So most problems in software are relatively common and can employ a reusable pattern. These patterns are formalized best practices that a programmer can implement in an application. There's lots of books on design patterns. It originally started with this book that people refer to as the Gang of Four book, and it's been localized to lots of different languages. So you can find the best way to implement design patterns, whether you're using Python, C++, C#, Node.js. You can find the best way to implement design patterns so that you can formalize and make it easier to work with the code that you've written. And so design patterns inevitably intend to make complex code easier to identify, work with, and read. So now let's go to the next slide, and this is the last slide before we conclude our lecture today, and talk about the values of extreme programming. So we've talked about this in many different forms, but let's recapitulate them. Rapid communication, constant, effective, face-to-face communication is key. Simplicity, remember we talked about maximizing the amount of work not done, implementing the simplest thing first, and then adding additional extra functionality later, only based on what is communicated as being absolutely needed. Constant feedback from customers, automated tests, and the team itself. You also have to have, with respect to values, you also have to have courage. And the reason why, courage is an interesting word, but it actually, if you're a developer, it takes courage to say that you're going to design code for today and not try and be as preventative as possible and design, potentially unnecessary code for tomorrow. It reduces what people also refer to as code bloat, and in that term I use dead code. You don't want any dead code. You want all the code being used, none that's not. It takes courage to do that. Another value is respect, where you have to respect the code base, your stakeholders, and of course your development team. So never commit any changes that break compilation, that make existing unit tests fail, or that otherwise delay the work of your peers. Usually software developers have a very important role, and they have to understand the magnitude of that role. So the last value I have is embrace change. Embrace the fact that what you have to do, or what you need to do today, might need to be refactored tomorrow. And someone else may take your code, change it in ways that you never intended. You have to embrace that. You have to understand that not just you own the code that you've written, you have to understand that the team owns the code, and the organization, and particularly also the organization. And so you have to embrace that requirements change, that the way to develop something as effectively as possible may change, and that your code, and that your thoughts, and your efforts may change by someone else taking them and working with them. And that is really what it means to have the values, the team values with respect to extreme programming. So let's move to the last slide, which we appropriately titled Conclusion. So in this class, we looked at how teams actually do software. We talked a lot about how people actually do software development, the nuts and bolts of what people actually do. We looked at the philosophy of developing in iterations versus predictive or waterfall environments. And we looked at this notion of agile, the philosophy of agile, and the ways people manage, develop over tight iterations. So if you're, and also we looked at, instantiations of agile with respect to management, Scrum, and with respect to development, with respect to extreme programming. And so if you're any way involved in software development in an organization that you go and work in, when you all become successful business professionals, if you're any way involved in software development practices, it's very, very likely you're going to encounter agile or some sort of iterative, tight loop development practice in some way. And so hopefully, if you encounter this type, any particular type of iterative development process, hopefully what we've talked about today and what you learn from what we've talked about, the case study and the stuff and the questions we're going to answer in class this week, hopefully, I hope, this gives you a leg up in understanding the nuts and bolts of how people actually do software development in modern organizations in this day and age. So, until next time, until next week, hopefully you get a chance to watch this slide cast, look at the case study, and do any additional work that we have scheduled for this week. And we have a great productive class this week. I hope you had a great break, and I will see you soon.